Okay, students, we've come to the final topic in chapter 4. We're looking at linear modeling. This last topic is all about more like problem-solving questions. When we talk about modeling, we are talking about situations that we can illustrate using a linear equation. Okay, so in life there are some situations that we can use a linear model or a linear equation to express what we're talking about. And example 19 is one of them, and I'm going to show you that. Okay, many situations often can be modeled by using a linear rule or graph. The key elements of this modeling include finding a rule linking the two variables. This rule is always going to be in the format of y equals mx plus c, okay? So that's something that we should never forget because that is our linear rule. Sketching the graph. So we're sketching the graph with a y-axis and an x-axis. We are also using the graph or rule to predict or estimate the value of one of the variables given. We're also finding the rate of change of one variable with respect to the other. So that'll be made clear as we go through this. This is equivalent to finding the gradient. Okay, let's have a look at one example here. So remembering that y equals mx plus c. Okay, the deal offered by NetShare, an internet provider, to its new customers is a fixed charge of $20 per month plus $5 per hour of use. Question A says, write a rule for the total monthly cost of C dollars of using NetShare for T hours per month. Now, remember, in our linear equation, we have two main variables. We have our y and our x. Our m is our gradient and our c is our y-intercept. So here we have already been told that we have two different variables here, our c and our t, and they've actually defined that for us. So we don't need to define that because it's already been defined for us. Okay, but this question says write a rule for the total monthly cost. Okay, so let's have a look at what the question says. It says, its new customers, there is a fixed charge of $20 per month plus $5 per hour of use. Okay, and we want the total for the month, the total cost, which is C. All right, so we're going to put C as our first thing, and that looks like this Y here, doesn't it? So that means our T is going to be our X variable. And let's have a look. It says, to its new customers is a fixed charge of $20 per month. So $20 gets charged every month, and the total monthly cost is that. So it looks like it's going to be $20 plus, and you see that there is a plus here as well, $5 per hour of use. If I have $5 per hour and there is T hours, it should be 5T. Let's put this in y equals mx plus c format. Y equals 5T plus 20. And you can see that the format is just like what we have up here. Okay, now in question B, it says sketch the graph. All right, question B should be over here because that's where my graph is. Now sketch the graph. Whoops. Sketch the graph of C versus T. Remember, our y-axis usually is on the vertical, so I'm going to do the same thing for this one. I'm going to make my C-axis there because that's what y is, and our t-axis is going to be where our x is normally. Okay, now this is saying that we sketch the graph of C versus T, using 0, to 10 for the t values. So we're looking at time at 0 all the way up to 10. Fortunately enough, my graph paper has enough intervals such that I can say that it's 0, 1, 2, and all the way up to 10. Okay, so, all right, now I'm going to just alter that slightly. Okay, so now we also need to go ahead and find out what our C intervals can be. Alright, so if I was just to make some rough estimates to begin with, have a look at my y-intercept here. My y-intercept is C, which is 20. So that means I've got to mark 20 on this side here. Now obviously I'm not going to go up by ones because I don't have 20 to go up. So instead I'm going to maybe go up by tens. Okay, so 10, 20, 30, 40, 50, 60, 70, we can keep going, 80, 90. Okay, so now if we have a look at this here, we do the graph. So remember, how do you sketch? Well, we sketch by first finding the y-intercept, that's 20. So we sketch by drawing a line at 20. And then we look at our gradient. So y-intercept, or C, is 20. Gradient is equal to 5 over 1. So 5 is the rise, and 1 is the run. So rise and run. So we go up by 5 and then across by 1. So here I'm going to go up by 5 and then across by 1. So then that's where my next one is. If I do that again, go up by 5 and across by 1, I end up here. Up by 5 and across by 1, I end up here. Okay, you can see that these are all going up by 5s. I could have made these go up by 5s on this in my cost, which would have probably helped me make this line a little bit more on the interval lines, but what I've done there is also fine as well. Okay, sketch the graph. So let's sketch the graph. That goes all the way through there. I might just adjust that slightly. Okay, that looks pretty good. Okay, that line is there, and I also write the rule here as well. Okay, now I've done part B. Let's have a look at part C. What is the total cost in a month when net share is used for 4 hours? So how do we do this? Well, net share is used for 4 hours. That is time, isn't it? Because C is cost. 4 hours. T is equal to 4 hours. If I use my rule, that's my main rule. 5t plus 20. 5 times 4, because that's my hours, and that's t, plus 20. Times goes first. 20 plus 20 is equal to 40. So $40. Okay. What is the total cost in a month when net share is used for 4 hours? Therefore, the total cost for 4 hours of use is $40. Okay, now let's see whether that actually works with the graph. Let's confirm that. If we start off at 4 hours, it looks like we hit here, this point here, which is 40. So that works there, okay? My line is slightly out just because of the way that it's been drawn, which then proves to me again why I probably would have gone through intervals of 5 over here. And because because my gradient is 5, that should have given me a bit of indication over here. Okay, but that's how we get that one. 4 and 4. Okay, now last question. I'll do D here. If the monthly cost was 50, so we're told that the cost is 50, for how many hours was NetShare used during the month? Write down my rule again. C is equal to 50, so that's where 50 goes. Now this is an algebraic equation you know how to solve. So I'm going to swap this so that the variable is on the left. Now what do we do here? What do we get rid of first? Minus 20. And I'll go over here now. 5t is equal to 30. How do I get rid of this 5? Well, I divide 5 by both sides. T is equal to 6. So, if the monthly cost was 50, how many hours? So, for a cost of $50, how many hours of NetShare was used during the month? NetShare was used for 6 hours. Okay, now we're going to use our graph to verify that we are correct. Okay, so if we go and get 6 hours, that matches up with 50. So you can see my line actually should have cut through there, but my drawing was a little bit off, okay? Even though we go through the correct points down here, they're still a little bit out. But when you do it on with pen and paper, you would draw it a little bit more accurately. Okay, so now it's your turn.